Hello and welcome to TidyX episode 81. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick, and you can find our screencast on Twitter at Tidy_explained, or send us an email to tidy.explained@gmail.com. You can always go on the GitHub repo where we have all the scripts from all of our 80 previous episodes, and you can open an issue there if you have questions, or if you just want to download the scripts, that's totally fine too.
All good.
Or you can go to our YouTube channel, and if you wouldn't mind, like, subscribe, leave a comment, leave a question, get in the mailbag. We'll get back to you and try and solve some problems.
Eventually, we promise.
Eventually, yeah, we promise. Also, on the YouTube channel, in the comments section, we'll drop a link in for our Patreon. It's honestly no big deal and no pressure. If you like what we're doing and you want to give back a little bit
Let
to
us
us
know
as
that
we
you
give
like
out.
it.
Yeah, exactly. Buy us a cup of coffee. We're totally cool with that. We both live in Seattle, where there's lots of good coffee, and it
We'd really
would
appreciate
definitely be appreciated. So
All
that's
right.
what we got.
That's what we got going.
Episode 81.
Yes.
We're going to jump in.
Yes,
We've
are.
done 4 straight episodes on Tidymodels. We've gone through the basic kind of flow of Tidymodels and Broom. We've talked about regression. We've talked about splitting our data. We've talked about tuning a random forest. Those are all regression problems. Now we're going to start into a little bit of classification. And the easiest place to start, per all of the textbooks go, is logistic regression, which is going to be trying to classify into a binary event, a yes or a no, a good or a bad, a win or a loss, playoffs or non-playoffs. And that's actually what we're talking about today as we look at some hockey data.
Yep, so let me share the screen here so that Patrick can see what we're talking about, and we can get going through the code itself. All right, so we're using our Markdown to format our code and write it all in there. We just like the way that formats, and it gives us little sections of code that we can run through. To get this code going here, we have, we're setting our chunk options to echo true so that when we render this, it will show all our code. We're bringing in library Tidyverse and Tidymodels for both our data manipulation needs as well as all the modeling tools that we're doing in this series. We're going to load some data. So the last several weeks we've done it on some air quality data that was provided from the datasets package that comes with R. But this time we're going to grab some new data, one that we thought could be fun given that hockey is happening right now in the Seattle area again. So we grabbed some historical hockey data from hockeyreference.com.
Yeah.
We just have stored a copy of it. We didn't want to go through the process of explaining the scraping that you can do to do that, but the data for this week is available at nhldata.csv. We load it in and use Janitor to clean up the names. So we're going to run that, and we end up with a nice data frame that is 62 rows long, 32 columns, so it's pretty darn dense, and this is a season summary data.
2 seasons worth.
2 seasons worth of summary data for the NHL. And then we're going to do a very quick data cleaning where we're going to take the NHL raw, which is what we just read in, and we're going to determine whether a team was a playoff team or not. And we're going to do that using the grepl function. So you may remember a few series back, we did a whole thing on regular expressions. So we're going to grep. So we're going to search to see if in the column team, if there's an asterisk, and if there is, it'll return true. And if there isn't, it'll return false. And then we're going to turn it into a numeric. So trues become 1, falses become 0s. And then we're going to convert it into a factor. So then it's going to be a factor of 1s or 0s.
And one of the important things, though, with that regular expression is our 2 little slashes there. So if those weren't there, this isn't going to work. Tell them why.
You need that. So this is escaping.
We got to escape.
Escaping it is meaning, hey, don't actually. So this is the asterisk there means something to grep into the search string where it actually says, okay, now use this and replicate it at least 0 or more times. But we don't want it to do that. What we want to see is, does it have an asterisk in it explicitly? And so you can do the slashes there, or you can set the fixed argument to true. This will be equivalent, because this will explicitly look for whatever this pattern is.
Yes.
So that is the other way to get around it. But
yep.
I don't know. I like writing it this way too. I don't know why.
That's me too. Yeah.
So now we have
explicit.
This NHL processed data set that has everything we had before, but it's got this playoffs field here that has whether the team was a playoff team or not.
Okay.
So now we're going to get into splitting, and I'll handle this one as well, and then Pat, you can handle the next couple groupings. All right, so now we're going to set our seed here because we want to do a split, and it does it randomly normally, so we want to make sure that it's going to do it consistently. We're going to use the function initial split. We're going to put in our NHL data, and then we're going to try to stratify by season. So we're going to run this and take a quick look, and so what we want to do with this model is take 2019 and apply it to 2020. But here, as you can see, it doesn't do a true split on season. And we were looking around, we're trying to sort out how you could actually specify, no, like I want I want a split on season or some other factor that you have in there and do a hard split on it. But we still want to maintain like the ability to be able to pass this NHL split, or what would be the output, into our models later on, because it's kind of nice to be able to do that. It handles a lot of the metric calculations for us. So it doesn't look like there is a method to do that as of right now. I wouldn't be surprised if it happens soon, just because it seems like there's a number of people asking for it.
Yeah, there's been a few issues open about it, so it seems like it's, there's times when you want to explicitly say, I want to split on this group to predict some other group or something
hard
else.
Split too, not like a
Hard
soft
split.
like I want to make sure that both appear in both groups. Like no, this is a hard split.
Yeah.
So you could just go about your way and manually split it into test and train and do that. But we wanted to, like I said, we wanted to take advantage of some of the tooling that exists in Tidymodels. And so what it is I use the function str, which is from base R, and it shows me the structure of the object that we're dealing with here out of NHL split. And so I kind of poked around with this, and really what it ends up being is a list that contains 4 different entries. The data, so this is the NHL data. Then it's got in ID. So in ID, based on kind of what I was looking around, is the in set ID. So this will be the training set that you'd be using, and it's a row, or it's the number corresponds with the row that it will be pulling out for the training set there.
All your row indexes.
Yeah, it's the row indexes. Out ID, my assumption is, because it's the logical NA here, my assumption is that is the out of set, so the test set. Yes, test set. But I also copied that, and then also ID. I think this means something to Tidymodels world, but whatever. And then it's got a class of MC split and R split. So I'm going to hack this a little bit, and I'm going to create my own version of the splitting, where I'm going to take the list, and the data is also going to be NHL exactly like it was before. My in ID will be the IDs where the season is 2019 or 2020. So when I run this will return to me the row indexes of that. And then out ID, I also left it as NA. I set the ID. I wasn't quite sure what this was. It's a Tibble. So I just guessed and wrote that. And then I set the class to be the MC split and R split, just like it was before. And I create this using structure. And as you'll see, it looks exactly like the splits that gets generated by initial split. And I'm able to run test and training on it, and I'm able to get it to return exactly how I want to. So this will be the 31 rows for train and the 31 rows for test, but now it's split by season.
So my question on that is, if you go back up to the top of this chunk, you stratified here by season, Technically, you didn't need to stratify by anything because you were going to create your own strata manually, correct? Like technically, that argument doesn't need to be there because you're going to do this anyhow.
Yes, so we didn't need to do this technically.
Right. Yeah, the whole thing.
Yeah.
Correct. Okay.
But
yeah.
I was doing it to show this is the normal process, and I would
structure.
be surprised if the Tidymodels team comes up with a nicer way to say initial split, hard split by this.
Something. Yeah. Exactly. Okay. Makes sense. Yep.
Yeah. So this is the only reason that we went through that. Is to cheat because we wanted to have it behave a specific way.
Yeah.
But all right, Patrick, do you want to take it from here?
Yep. So we'll create one last split of that training data, and that's going to be our cross-validation folds so that we can, again, it's small data, so we'll just use a bunch of folds, in this case 5, to build models over. And here, because the outcome that we're predicting is going to be playoffs, we're going to set the strata to playoffs to ensure that there's some equal samples within each of those 5 folds. So we'll go ahead and, because this is a random generation sample of the data, we're going to set the seed. And now we have our 5 folds, and you can see it's split on 24 to test, to train the model, 7 to test it, 24, 7, 25, 6, 25, 6, and then 26, 5. Cool.
There you go.
So now, as we do in our kind of Tidymodels framework, we initialize the model of interest. In this case, we're building a generalized linear model. It's going to be a logistic regression model. So we use logistic reg, and then we pipe in that the engine we want to use is GLM. Just like standard R, if you were doing logistic regression, you'd use GLM for generalized linear model. And then we're going to set the mode to classification. Probably don't need to set the mode to classification because logistic regression is by default classification. But just good practice if we were going to ever change this to random forest or XGBoost or something else type of model, we would need to specify that mode. We specify the model, and now we have a GLM model specified, and it's ready to do some work for us, but we're not ready for it yet. First, we need to set up some recipe and our workflow. So with the recipe, unlike the previous episodes, this is a really clean data set because we pulled it as is. So there's no steps for us to have to like pre-process or impute anything. We're literally going to roll with the data as it is. We're specifying our actual model that we're interested in. So here we want playoffs, and we want goals for per game plus goals against per game plus save percentage. So a measure of offensive production, defensive production, and goaltending, and whether or not those can predict whether a team makes the playoffs or not. The one thing I'll say is the reason why I went with playoffs in this model, I originally wanted to do win percentage, and I wanted to write a binary logistic regression where the dependent variable was 2 columns, a column of success and failures, wins and losses. And I would do that with cbind, parentheses, win, comma, loss. We did this in a previous episode, and I have to figure out which one it was, but it wasn't supported by Tidymodels. So maybe I'll write up something and open an issue for that, because that would be a pretty cool one to do. But for this week, we're going with playoffs. We've got our recipe specified, so if we run that, we'll be able to then take a look, and this recipe obviously says we have 1 outcome, 3 predictors. We're ready to go. We're going to throw it into a workflow, and then we're going to build our model. Okay. Throwing it into the workflow. We're going to initialize the workflow. We're going to add the GLM model that we initialized up top, and then we're going to throw in the recipe there as is. So now we've got a workflow, and this houses all the information about our logistic regression model. It tells us the type of pre-processing, which we're not doing any. It tells us the model type, which is logistic regression, and it gives us all the information that we need to know, which engine we're using, etc. Before we fit the model to our actual data, we want to crank through those cross-validated folds. So we're going to take that workflow and we're going to pipe it into this fit resamples function, which is basically telling Tidymodels that we want to fit the model to those cross-validation resamples that we're using. The object is the GLM model. The pre-processing is our recipe, of which there isn't any other than it specifies the model type or the model equation. Yeah. The resamples are our cross-validation folds. And then the metrics, this is always going to default to the kappa coefficient and accuracy, but we decided to show that you can also throw in there's a lot of huge yardstick and metrics, and you'll see there's a whole bunch of metrics that are supported for validating your models. This one, we just threw in 3. We put in the area underneath the receiver operating curve, the kappa coefficient, and accuracy, the 2 default ones. So we run this, and it's going to crank for a second. It's going to run through our folds, and now we have our model actually fit to those cross-validation folds, and we can yank out the metrics of this model. So there we see our accuracy, our kappa coefficient, and our ROC. We can see the mean value. So this is the mean over the 5 folds that we fit, and we get a measure of our standard error, so how much variability there is across those models. And so cool. If we're happy with where this model is, we can go ahead and now fit it to our actual data. So here, we're going to fit the model and then make some predictions. So we're going to take the entire workflow. We're going to say last fit. Unlike the random forest from last week, where we needed to specify that we wanted the best fit, this has no tuning parameters, and we're happy with where the model is. So we're just going to take the last fit of that model. We're going to put in the split is going to be on the NHL season split. So it's basically saying, hey, last fit the model to the train set, and then dump it onto the test set so that we can test it out, and then get us those same model metrics. So tell us how well we did on the test set once we take this model and apply it to our out of sample data. Okay, cool. So
split.
And it's all split, and we're ready to go. Let's throw some predictions on this. We're going to bind calls. So we're going to take our NHL test set, our test data. We're going to take the fit NHL. So this is the model fitted. We're going to collect the predictions. So this is all the predictions in a nice little tibble there. You can see each one. So you can see .pred 0 is the probability of being in class 0, not playoffs. .pred 1, probability of being in class 1. Row is going to be the row ID.
So which row does it feed to in the data set?
In the data set, yep.
Test data set.
In the test data set, correct. Pred class is going to be what was predicted. So that's going to be based off of those probabilities of 0 and 1 with a default of a 0.5 cutoff. So pred class will be a 1 if it's above 0.5, a 0 if it's below. And then playoffs, which is our actual observed outcome, right? That's the ground truth. Mm-hmm. So we're going to grab those collect those predictions, and we're going to select starts with .pred. So we want the predicted information basically to lop onto our original NHL test. And we're going to throw this into a new data frame called NHL test pred, which houses all of our original data and then any of the columns from the collect predictions model that had the .pred underscore within their name. Mm-hmm. And there we can just pull ahead of that, and we can look at the key columns of interest in this case, and we can get a sense for the prediction accuracy by looking at a simple little 2x2 table, a confusion matrix, which we build right there. So I took table, and I actually name these so that I remember what I'm looking at, because they are 0 and 1. So on the vertical is the predicted class. Across the horizontal is going to be the ground truth, and you can see that it was very good at predicting zeros, so predicting no playoffs. It had 0 misses. There were 3 instances in 2020 where it thought a team should have made the playoffs, and they didn't. So perfect.
I mean, it's saying that they were probably a good team, but they just weren't quite good enough compared to the other teams.
Yeah. We can take that NHL test pred data, and we can actually print out an ROC curve with the auto plot function. So there we go. So sensitivity on the y-axis, 1 minus specificity on the x-axis. The closer that this curve gets to 1, to the upper left corner, the more accurate the model is. And you can use different thresholds. Obviously, you can go in and set different thresholds for your prediction, depending on if you want more sensitivity or specificity. Oftentimes, that's depending on the cost of getting it wrong, right? True positive or false positive. Probably not a big deal here for predicting whether teams are going to make the playoffs, but maybe if you were doing something in like medical research where there's a higher cost for making a mistake in one direction or the other, you're going to want to change those thresholds and be a little bit more specific. And then the other thing we can do is we can take that same final kind of NHL test pred data set. We can yank out the actual receiver operating curve, area underneath the receiver operating curve, the AUC. This was one that we spent a bit of time on, and this is why reading the details of the function is super useful. So when we originally ran this, we had what did we do? So
we tried to convert the prediction, like 1 or 0 prediction.
Yes, that was a problem. It takes probability as the second argument. The other issue was this default issue. So we originally ran this with .pred1 because we were like, hey, show us the area underneath the operating receiver curve.
Here, I'll show that just because we're like, this is the one we're trying to predict. Of course,
so we were like, yeah, show us playoffs compared to that. And when we ran it, we're like, there's no way. I mean, just looking at the figure to your right, that is way bigger than 7.5%.
I mean, so those of you that don't know ROC AUC, this is looking at this receiver operator curve here and going, what is the area underneath all of this?
Yes.
And so typically you'll end up somewhere between 0.5 and 1. 1 being perfect prediction all the time. You 100%. If you're getting that, something's wrong with your model.
Probably. Or it's not going to generalize well.
Yeah. And if it's less than 0.5, that actually means your model is just guessing inversely.
Yes.
So it's guessing the exact opposite of what
you want.
What you want.
So we got that, and we're like, well, there's no way. And then we read some of the the information about the function itself, and we found that it actually defaults to the first level within the prediction class. And so remember, we have 0s and 1s, so the first level is 0. And so if we actually then set this NHL test pred ROC AUC function to .pred 0, because it defaults low, now we're at 92.5%, and that's the correct AUC. We could alternatively have set the level to what was our class of interest, which was prediction class 1. We just have to make sure, because it defaults to the first level, we want to make sure that we want to pick the second level. Mm-hmm. And then finally, to wrap it all up, we can grab our collect our metrics and put a bow on it. And there you can see that obviously the metrics here are less impressive than they were on the training set and on the cross-validation set, as to be expected, because it's new data. It's not a lot of data, but it is new data, and so the model struggles a little bit with real-life data. And that is a way to simply fit logistic regression within the Tidymodels framework.
There you go, everybody. And that's all she wrote for this week. Thank you all
Happy classifying.
so much for joining us for 81 episodes of TidyX here. We appreciate you all joining us. If you like what we're doing, please subscribe. Please like this video. Please leave a comment. If you want to support us continuing to work on this sort of work, once again, no pressure. We'd appreciate it if you signed up for our Patreon. Patrick, do you have any other things you want to say?
No.
I
think that's it.
We'll always
continue on with Tidymodels a little bit more next week.
As always, you can find me on Twitter at Ellis_Hughes.
And I'm on Twitter at OSPPatrick. And Tidymodels. Tidy Explained on Twitter at Tidy_explained. Tidy Explained on Gmail at tidy.explained@gmail.com. The GitHub repo is always open for issues and comments. And the YouTube channel, as Ellis mentioned, we love getting the comments and questions there and responding to those. So keep them coming, and appreciate you watching.
All right. Thank you all so much, and keep on exploring your world.